What's up, guys? This is my first activity in Ichthyology, and it is all about scales. Now, first of all, what are scales? Scales are small rigid plates that grows out of an animal's skin to provide protection and is generally classified as part of an organism's integumentary system. Now, the study about scales is called squamatology. And in the development and location of these scales, they're actually produced in the mesoderm, located between the epidermis and the underlying tissues. Genes responsible for the development of scales in fish are the same that result in hair and tooth development in mammals. These scales grow on a fish in overlapping plates, with the free end of the scale pointed towards the tail. Now let's head on to the functions of scales. Scales provide external protection to its body as scales are tough and slippery, preventing harm from scrapes, parasites, and other external injuries. And since they're all attached at one point, they allow flexibility for the scales to slide over each other as the fish's body bends while swimming. The structure and configuration of scales can be used to determine the species from which they came, and the type of scale will affect the behavior of the fish. For example, large, heavy scales provide more protection but they restrict movement. Smaller, lighter scales offer more freedom of movement but less protection. Now, let's talk about the types of scales. In this video, we'll be mainly talking about 4 types, and they belong to the modern types of fish. First, we have the placoids. Placoid scales are commonly found among sharks, skates, and grays. Second, we have ganoid scales. Ganoid scales can be found on gars, bichers, and reedfish. And leptoid scales can be further divided into cycloid scales, which consist of most bony fish, and ctenoid scales, which belong to a variety of perch-like fish. Let's start with placoid scales, formed of a rectangular base plate that's embedded within the skin of the fish. The interior of the scale is a pulp that receives blood from the fish's vascular system, while the outside is made of an enamel-like substance called vitrodentine. Placoids have a sharp enamel ridge down the center of the scale called an ectodermal cap, which is important since sharks can't feed without it. They don't grow with the fish. Instead, a space grows in between the scales where new ones grow to fill in the gaps between the other scales. Let's proceed to ganoid scales. As mentioned before, they can be found on gars, bichers, and reedfish. That being said, these scales are rare among modern fish. These scales are flat, basal-looking scales with an unusual characteristic among other scales, which is the fact that they don't overlap, but instead they fit together like pieces in a jigsaw puzzle. They have a bony base layer similar to cosmoid scales, which we'll get to in a minute. This just shows that ganoid scales are just modified cosmoid scales. However, they differ in that their outer layer is made of an inorganic bone salt called ganoine, and that they are diamond-shaped and interconnected. In between the scales are peg and socket joints that articulate. They act like armor to form a nearly impenetrable barrier to predators. They actually grow with the fish in length, width, and even thickness. And now We're at leptoid scales, which are found on higher order bony fish, and as the scale grows, they add concentric layers. That being said, this category can be further divided, as previously mentioned, into two other types: cycloid scales and ctenoid scales, where both of them are often grouped together as bone-ridged scales. Let's continue with cycloid scales. Now, cycloid scales and ctenoid scales have different shapes, but have the same composition and positioning. Cycloid scales are also called round scales, and the vast majority of bony fish have them. These scales have a smooth outer edge and are most common on fish with soft fin rays, such as salmon and carp. These scales have two basic parts: the inner solid structure made out of bone and an outer layer made of collagen. These scales are not shed as the fish ages, but they grow with the animal. The result of this is that a fish can be aged by counting the growth rings, similar to counting the annual rings on the tree. Now, there are some species that have skin structures that are easily shed, known as deciduous scales, such as herring and other groups of bony fish, which have large cycloid scales that fall off really easily. And now we're at the last type of modern common scale, which is known as the ctenoid scale. These scales have a toothed outer edge that are exposed, which can be seen as spiny or have comb-like ridges, which are commonly found on fish with spiny fin rays, such as bass, crappie, and some species of gourami. They have tiny teeth-like protrusions called ctenoe, giving them a rougher texture. Now, there are also another less common type of scale, that is the scute scale. These are an external shield-like bony plate of a modified thickened scale that are often keeled or spiny. An example of fish with such scales is the pinecone fish, which are completely or partially covered in scutes. There are also fish that lack scales that are referred to as scaleless fish, such as gobies and toadfish. Instead, these fish are covered in a coating of slime, which will protect the fish from injury and ectoparasites. The slime layer may even serve the added function of making them hard for a predator to grab onto them. Now, there is another type of scale, which is the cosmoid scale, but they commonly belong to extinct species during prehistoric times, such as the Crossopterygians, but nowadays they're limited to the primitive lobe fins, lungfish, and coelacanths. Now, cosmoid scales actually evolved from placoid scales, fusing together. This is because cosmoid scales have two base plates and similar external spines composed of vitrodentine. The inner layer of the scale is made of lamellar bone, while on top of this lies a layer of spongy or vascular bone, and then a layer of dentine-like material called cosmi. These scales grow along with the fish. This type of scale is not further discussed because we're talking about the more common scales in the modern world. This is my preserved bichir. The scientific name is Polypterus senegalus, common name Senegal bichir. And when he died, he weighed 27 grams, was 7.5 inches long or 19.05 centimeters, and the reason why he died was he was attacked by a snakehead. This is my preserved specimen for ctenoid scales. It's a 3-spot gourami, scientific name Trichopodus trichopterus. It weighed 14 grams upon death and was 3 inches long. Its cause of death was ammonia poisoning. This is my preserved specimen for cycloid scales. He's my prized Benja red Asian arowana, scientific name Scleropagus formosus. At the time, he weighed 625 grams and his current length is 48.26 centimeters or 19 inches. Cause of death was physical trauma. This is my preserved specimen for placoid scales. Scientific name Trigonoptera testacea. Common name is a common stingaree. Current weight is 275 grams. Current length is 6 inches in diameter or 15.24 centimeters. Cause of death, impalement. And that's it for this video. I'll see you again later.